Hello everyone and welcome back to another video. Today we'll be taking a look at our chess engine, and in this particular video it's a very special video. We'll be taking a look at the play function. So this play function is the function which basically puts everything which we've done so far together into one function, and it basically actually plays the game. So it's a very exciting function. We'll be basically, this is the function where we put literally every other function inside this entire code together, and this is where the bot actually plays against the human player. So let's have a look at where exactly this is. So if you're following along on GitHub, as I'd recommend you do, it's on line 683, very close to the end. It's actually the final function which we're going to look at. And basically, it only takes in two parameters as input, the depth and the number of positions. So the depth is basically the how far you want to explore, and the number of positions is how many positions you want to explore on the first move. So for example, a depth of 6 and positions of let's say 20, that would basically correspond to a depth of 6 means 6 half moves, which means 3 full moves. So in traditional chess, a depth of 3 corresponds to basically 3 moves for each side. So that would be the same as a depth of 6 here. So basically we looks at 6 moves in total for each side, and then the number of positions, 20, would basically mean that it looks at 20 positions and then evaluates each one of them, and then it determines which one's the best one, and then whichever one's the best one, it decides to play that one. So as you can imagine, having more positions means that you can explore every single possible move, which is obviously better, since let's say if only the 30th position which you looked at was the best move, then if your position was less than that, then you wouldn't actually find the best move. And then also having a depth greater is better, because that means you can look into the future even more. So you're more likely to get a more accurate evaluation of whatever the position is, so you're more likely to play a better move. So these two are the only two functions, only two parameters which it takes in. And now everything else it basically determines by itself. So there are basically two main parts to this. So one side is integrating the UI into this function. This is basically, if you remember, quite a while back now. But the UI is basically just drawing the grid, squares, and also endgame text. So this endgame text will basically just be, the text which is displayed at the end of the game. Like for example, like white has been checkmated or whatever. And that's one part, displaying the actual moves. And one other main part is taking in the moves from the user as input. So this would be of the sort, let's say you click 2 squares, and then you move a pawn from one square to another, then it'll basically take that as input. So which is basically how exactly this play function works. So and now that we have that under control, like just a high level overview of what this does, let's have a look at how exactly this works. So I'll just run through the UI after we go through the actual core logic first. So basically what we start with is, first of all, if it's the middle game, then if it was not already the middle game, then basically, as you mentioned, the middle game is basically initialized to true, since if we ignore the opening stage, then it's always the middle game from the start until a certain point where it stops becoming the middle game. So basically, if it's not the middle game, then if it's no longer the middle game, then we basically need to change how exactly we evaluate the king positions. So this is what we were looking at briefly in the last video, or 2 videos ago, when we were looking at the is middle game. So just briefly to recap, the is middle game just checks whether it's the middle game or not. And the reason why this is important is because the evaluation of a certain position based on the king position will basically change drastically whether it's the middle game or not. So if it's the middle game, and if it was not already the middle game, then we basically change the ultimate location of the king. We basically append the king endgame instead of having the king middle game. So the king endgame is just the array of best positions for the king endgame. If you don't know what this stuff is, then look back a few videos ago, actually several videos ago now, when we went over the evaluation function. Or if you just need a quick refresher. And then after this, we set middle game to equaling false permanently. And then basically, now also another thing. is we initially this is just taking the input of the move from the user from mouse click, but and we'll come on to that a bit later. But then we basically need to actually play the move which the user says. So the coordinates are basically going to be okay. I'll come on to exactly what this does later. Sorry if like I'm saying this for a lot of things. The reason why is because everything's quite interconnected with this function, and the most logical way is to go over like the actual core logic side and then go over the UI side, which is still very important, but not as important as the logic. So clicks 1 and clicks 2. For now, clicks is basically just the array of storing the moves which the user made, the first move and the second move, i.e. the starting coordinate of the first position and the ending coordinate. So we basically just carry out that move, and then we update the self.grid and self.piece locations accordingly. And then after we do this, what we basically do is we need to iterate for each color and see whether checkmate is true, whether it's checkmate or not. And if it's checkmate, then the game's basically finished, so which is why we draw the endgame text, i.e. black wins by checkmate, white wins by checkmate. And then we basically need to finally display it once more, and then we basically just, that's where we conclude our entire procedure. However, if it's not checkmate, then what we basically do is we reverse the color. This is very important, since the color was basically, it was a human player who played this move, but then now the color will be reversed. So the bot knows to look for a best move for this particular color, the new updated value of the color. And then we basically, the alpha and beta from the previous video, alpha and beta basically just pruning values. And we set this to equaling minus infinity and plus infinity, i.e. just null values initially, so we don't prune any unnecessary branches. If you're not sure what I'm talking about, just feel free to watch the previous video again. It explains that in a bit more detail, or just watch maybe another video explaining what alpha beta pruning is. That might be more useful. And now we have the selected move and evaluation, which we take from this. And now whatever the selected move is, we basically need to carry out this move. So we basically carry out the selected move, the x coordinate, y coordinate, as well as the piece locations, and then we finally update the piece locations and grid one more time based on whatever the selected move was from whatever the chessbot thought was the best move. And the way this is determined is the decide move function, not the best move function. The best move does a static evaluation. The decide move looks a few moves into the future, which is what we went over in that last video. Okay, so now we actually carried out our move. Now what we do is we basically do the self.piece locations and self.grid. We update them correspondingly. And then finally, we also need to check whether it's checkmate in this particular position. And we basically just copy paste the exact code which we had over here again, since since we need to check if the chessbot has meted the engine, meted the UN player. And then we basically, that's pretty much it for the logic side. And now let's go over the UI side. Okay, so if we basically consider what exactly needs to be done for the UI. So we need to continuously display the visualization of the chessboard. And then we also need to take in a few inputs from the user. So the inputs which we need to take from the user are basically the coordinates of the move which they're playing. And what exactly does that mean? So it's the starting coordinates and the ending coordinates of the move which they're playing. So now the way in which we initially do this is this over here is basically just responsible for the actual display. So we basically just initialize the display mode. It's equaling width and height. And then we fill the screen with white. This could literally be like any color. This could be like blue. This could be like cyan. It doesn't really matter, but we've just chosen white. The reason why this doesn't matter is because this will basically get over, this is the bottom layer, and then it will get overdrawn by the drawing squares. So this drawing squares basically decides to draw the squares, alternating obviously like a chessboard. And then we also initialize the clock. So this clock is basically responsible for the refresh rate. So what this does is this basically, let's say the clock is set to like 10 ticks. This basically means every 10th of a second, it takes in any input, any user input from like the mouse click, and then it displays any new positions. So for example, let's say the UN player played a move. Since the refresh rate is every 10th of a second, it'll basically play that move out. So which is where the clocks clicks come in. And then we also just set the display.set caption and image.load. So the caption is basically just chessbot. Like it's basically, if I just run the bot over here and show you, you can't actually see it because of the way the screen's laid out, but you just have to trust me on this one. Like if you follow along on GitHub, then you basically see the icon, like this particular icon, which is somewhere. Let me see if I can just hover over this. Maybe it'll turn up. Yes. Okay. So this particular icon, like it just shows a random icon, but and this chessbot screen, like it's just like minor UI things over here. And then what we basically do is we need to also, as I said earlier, we need to take in the input from the user. So for each of the events, first of all, if the event is p.quit, this basically means that if the event is like a quit command, then you basically just need to exit out of the program. So the quit command is basically if you just press the red X on the top right corner. For example, if I were to press this red X, and now if it's this case, then we break. Otherwise, what we basically do is we basically set the if the event.type is a mouse button down, so and like I either click that mouse button down, literally exactly how it says. If that's the case, then we basically need to get the position of wherever the click was, and then determining which coordinates the position of the mouse click corresponds to. And then after we do that, we append that to the clicks array. So clicks array basically stores whatever the moves or whatever squares the user has clicked on. So if the user clicked on two different squares, i.e. if the length of the clicks array is 2, then first of all we do this. If the clicks is not equal to the clicks one, since in this particular code, if you want to deselect a square from clicking, then what you do is you basically click it twice. So you click it once, then you click it again. And then, however, if this is not the case, then if this is the case, either way we clear it. If this is not the case, then the user has actually made like a certain move. And now, after they've made a certain move, then we basically just need to carry out this move. So we carry out the move function on this particular move. And then what we do is we also we also need to determine whether it's checkmate, and then exactly how we did earlier for all of these different things. And then now finally we basically just need to constantly display this, and then clear the clicks after every move. Okay, so and now that's pretty much it for this play function. Now let's see this actually in action, and we'll be doing that in the next video. Okay, so I really hope you enjoyed watching this video. Hopefully you learned something new. This is basically how we put everything together, which we've done in the past, like probably like 10 videos now, all into this one function. So now that basically concludes our exploration of the chess engine. I really hope you enjoyed this series. Hopefully you learned something new. So is it something? It's been like a really great experience. And if you enjoyed any of these videos, please be sure to leave a like and subscribe. It would be very much appreciated. And I hope to see you in the next video, which will be the final one concluding the series. Thank you very much for watching. Bye.